Good morning. Let's get started. Okay. On Thursday, we're going to be back here in the computer lab again. Our last meeting together before the long spring break vacation. Homework 10 is going to be due on Sunday. We've got midterm exam 2 on Sunday, and then the project will be due the following Sunday after that. I apologize for the lengthy delay in getting your homework assignments graded. I've just received these back from the grader. So here is homework 6 and homework 7. As you leave the classroom today, at the end of class, you can come and pick those up. And he's promised me that homework 8 and 9 will be finished in time for me to give it to you on Thursday. So that being the case, then you will have all of the homework that's been accumulating that you'd submitted back to you so that you can refer to it as you study for the exam. Any questions related to the announcements? Okay, today we're going to be talking about incremental benefit to cost analysis. And we've done both of those things individually before. We've previously done B to C analysis, last class period. And we've also done incremental analysis before. That's when we were comparing alternatives and finding out if the extra amount for the next most expensive option was justified. Before we get into the new material, let's talk briefly about exam 2. So exam 2 will be here in this classroom. The format and the operation of the second exam is going to be essentially identical to that of the first. So there will be questions that are like conceptual questions. There will be problem solving that you'll do by hand. And so what I'll do on the exam is I'll clearly differentiate between the problems where you can use Excel and those that you can't. And then at the back of the classroom, I'll be keeping an eye on things. So there will be some problems where maybe I'll ask you to use the table lookup method as you do the problem, some where you maybe will be asked to use the equation method and so on. And then, last time we only had one Excel problem, and I think it'll be the same situation this time where there'll just be one problem that you solve using Excel, and then you upload your Excel file to iLearn so that I can have both the answer that you write on the page and then also look at the spreadsheet that you make. There will be 50 minutes available, and so any questions related to the format of exam 2? So just to reiterate, we're going to meet today and Thursday, and then there will be a one-week delay where we're not seeing each other. Hopefully during that week you'll be doing homework 10. In fact, you could do homework 10 even before the break begins. You could have it finished. You could get a good part of it done today if you'd like. But then the project, after spring break, there will only be 1 week to finish the project. So I'd really encourage you to try and get a good portion of the project done during the break because you'll be very busy during the week after spring break. So don't leave it to the last minute. All right, so let's talk about incremental analysis. When we were doing incremental analysis before, we were doing incremental rate of return analysis. And so we were talking about the sorts of projects that are used to generate a positive return. It's like a private company makes an investment, and in one of our examples we were comparing different types of construction equipment like Caterpillar versus Komatsu, Mitsubishi, Hyundai, and so on. And what we had done in that analysis when we were doing the rate of return analysis was we organized things from cheapest to most expensive. And then what was our criteria? Do you remember what was the criteria when you were comparing one option to the next? How did you know if you should say yes to the next most expensive option? Okay, you're comparing the IRR to the MAR. And so you were looking at what's the internal rate of return on the increment, meaning, if the Hyundai costs $100,000 and the Mitsubishi costs $110,000, the question becomes, should you spend the extra $10,000 to buy the Mitsubishi? What does the additional investment get you in return? And so you were doing an analysis just on the difference between the two alternatives, and then the criteria was, yes, you should do the next most expensive option if the rate of return was greater than the MAR. So on projects that are publicly financed, we have to change our thinking a little bit because there's not going to be an internal rate of return. You can only calculate the internal rate of return when there's a positive cash flow. And a lot of public investments like parks and hospitals, fire stations, sewer systems, and so on, a lot of those don't generate a profit. They may have some revenues to help offset the costs, but they're not profit-making enterprises. So we can't use rate of return analysis. We have to do benefit cost analysis. So here's what this incremental analysis we're going to do today is all about. We are going to compare the difference in the initial cost between two options, but then we're also going to look at the difference in the maintenance and operation costs between two options. We're going to look at the difference in benefits that they each generate and the differences in the disadvantages or the disbenefits. Now, we're going to have to move everything to a consistent time frame so that we can calculate the ratio. This ratio only works if the benefits, disbenefits, and the costs are all at the present, all at the future, or all on an annual basis. It wouldn't work, it wouldn't make any sense if the initial costs were at the present and then the maintenance and operation costs were on an annual basis. We'd be adding money at different times. And we have to have all of the money at the same time before we can calculate the ratio. And the same is true for the incremental analysis. When you're comparing option A and option B, you need to take all of the costs to the same time before you can compare the two options. Okay, so we're calculating increments, taking them to the same time, and then we substitute into the formula, but we have an illusion we have to be careful of when we do problems like this. Sometimes the option with the highest B to C ratio is not the option we should choose. You remember, we had something similar when we were talking about internal rate of return. There was an illusion we had to be careful about. And what was the issue with that one? When we were doing rate of return analysis, sometimes the one with the higher IRR really wasn't the best choice. How come? Yes? Because the initial investment was different. And so the illusion there was, remember, it's better to get a slightly smaller return on a big amount than to get a high percentage return on a small amount. Because what we really want is to maximize our profits. We don't want to maximize some arbitrary percentage. We want to maximize the amount of money that's going to our pocket. Now, the illusion on these is that you can't pick the best alternative by just calculating the B to C ratio. You have to do an incremental analysis when you're comparing alternatives, because anytime you can spend $1 or a dirham and get more than $1 or a dirham in return, you should definitely spend that money. So let me put it a different way. If you came to the front of the classroom and you gave me a 100 dirham note and I gave you back a 200 dirham note, you should definitely do that trade, right? I shouldn't do that trade, but it would be good from your perspective. What if I changed the offer? What if I changed it to you give me 100 and I'll give you 150? You should still do the trade, even though it's less than it was before. You know, the previous offer you were getting 200. You should still do the trade. What if the offer is I'll only give you 105 dirhams for every 100 that you give me? Keep doing it as long as you get more back than you're giving. And so the same is true in incremental analysis. You're not looking for the maximum ratio. You should just keep doing your investments as long as you get back more than you are putting in. And so that's what we're going to see in today's example. I've got the in-class exercise that I'm going to give you in a moment. I've got it set up so that order by order, you're first calculating the B to C ratios, and then I've created the example so that there is that illusion that you have to be careful of, where the one that looks the best just from the B to C ratios isn't actually the best one. Good question, good question. So he's asking about the time period. as long as we take everything to the same time, so if we take everything to the present or everything to a future, remember this ratio, all of the components of the ratio should be in the same time. And so what I'm saying is, the exchange that we were doing, the example where you were giving me a certain amount and I was giving it back, that was just meant to simulate the ratio once we'd calculated the B to C ratio, where your cost is 100 and the benefit you get from me is 150. We're doing that exchange right now in the present. But it maybe would be a little bit different if you gave me 100 and then you didn't get the benefit for 50 years, right? That could change everything completely. And so to avoid that issue, we're taking every component in the B to C ratio to the same time frame. Okay, here's today's exercise. Let me hand out the papers. A lot of times I give you the format that the spreadsheet is supposed to be in. Today I'd like you to try and figure it out on your own. I want everyone's spreadsheet to look a little bit different, just the way that you can envision solving the problem. I'm not going to leave you completely hanging, though. If you really get stuck and don't know what to do and are starting to get frustrated, the template is on the back. So one template, not the template. There is a template on the back side of the paper there, but I'd like you to see if you can solve it on your own. All right, so let's take a look at what we've got here. We have several different options. We've got option A, B, C, D. Option A is the cheapest, 3.2 million, and they're increasing order. And this is a dam project. We can choose different types of dams, and depending on how much you spend, there are differences in how much they cost to maintain on an annual basis. So the costs, you can see, there's two different categories of costs. There's the initial construction cost and then the annual maintenance and operation. The benefits, there's different kinds of benefits. This dam is going to help with preventing flood. It's going to have fire protection benefits and then also recreational benefits because maybe people are boating on the reservoir or catching fish, something like that. But then there are also disbenefits. And so if we just look at it at first glance, it seems like option D has a lot less disbenefits than option A. Some of those amounts most of them are annual, just the initial construction costs are in the present. So what I'm asking you to do as your first step, step A here, is find the present worth of everything for each alternative. And then step B is find the B to C ratio for all four alternatives. And then part C is really the meat of today's exercise. It's where you're going to calculate the increment. So find the difference in the costs, the difference in the overall benefits, the difference in the disbenefits from one option to the next. And remember, when we do an incremental analysis, let's say that we're comparing A and B. If B is rejected, what's our next comparison? If we're comparing A to B and we reject B, then what's our next comparison? It's A and C, right. We forget about B. We wouldn't do C versus B because we've already rejected B. So remember that when you accept something, you forget about the last one that you had as your option. And when you reject something and you move on to the next alternative, then you roll to the previous one before that for purposes of comparison. All right. So I'm going to stop talking, let you get started on Excel. Of course, the first thing is just to copy this data in its entirety into the spreadsheet. But see if you can figure out a way to do, the concepts in your mind. You know what calculations need to be done. You're going to be taking some payment amount to a present value. So that's, converting the annual amounts to the present. I'd like to see if you can set up the spreadsheet yourself. And don't use the cheat sheet on the back unless you're just at your wit's end and don't know how to proceed. All right. So you should find the PV function. For instance, we've got $52,000 per year for maintenance and operation, 75 years, and a 6% discount rate. So if we want to find the present worth of that expense, then we would say equals PV, the rate, 6%, N is 75 years, and then the payment amount is 52,000. That means it's going to be 52,000 75 times. So that tells us that the present value of that payment is $855,704. So the PV function will do what you need it to do for this one. It's the same formula as before. It's still the conventional, but I'm using the delta amounts.
Oh, the delta amount. Oh,
Yep.
thank you.
Mm-hmm. All right, so maybe you're still working on your calculations, but let's talk through the concepts because that's more important than just putting the numbers into the machine. Let's talk about the format of what this all means. So we started off with the given data, and fortunately for us, the given data was already presented in terms of cheapest to most expensive. So if you have data that isn't yet sorted like that, the first thing you do is sort your data based on the initial cost, from cheapest to most expensive. What we did as our first step was found the present worth of those annual amounts. Now the initial construction cost was already in the present, so you don't need to do anything for that, but the maintenance and operation, these benefits, and the disbenefits, all of those were recurring amounts. It was how much every year for 75 years, and so you need to take all of those recurring payments to the present and find the present value. And so we use the PV function for those amounts, where we were using the interest rate that was given, 75 years, and then the amount that was shown in the payment field. And of course that negative sign, because Excel changes the sign, and we want it to stay as a positive value. So this is the present worth of everything, and then we found the B to C ratio by just using the formula. The conventional B to C formula is shown here. Benefits minus disbenefits divided by costs for the initial upfront plus the maintenance and operation costs. And so that is how we found these. And the illusion you have to be careful of is it's not about which has the highest B to C ratio, because by that judgment, B would look like it's the best. But it's not. When we go through the incremental analysis, we're finding, for instance, in comparing B and A, how much extra it costs. It costs an extra $780,000 in construction costs. Here's the extra maintenance and operation costs when we take it to the present. The incremental benefits comparing the two, the incremental disadvantages. So a minus sign on the disadvantages means that option B has less disadvantage than option A. So it should be a negative amount. When we put it into the incremental benefit to cost, it's the same formula as before. It's going to be benefits minus disbenefits in the numerator and initial and maintenance operation costs in the denominator. So this 2.57 means that the 780,000 extra, the costs are justified because you're getting 2.75 times as much benefits as you're getting costs. So you should definitely spend the extra amount. Even though option A is a good option, option A has a positive B to C ratio, option B is better. And this proves it. Option C isn't better though, because when we do it, we find that there are more costs than benefits. That's why that ratio is below 1, is because when we look at the benefits, they aren't better than the incremental costs. But then when we compare B, which looks like our winner, to option D, It costs 5.6 million more. So option D is a lot more expensive than option B. It's a very costly alternative, but it's returning so much in terms of additional benefits and reduced disbenefits that 1.12 means that the extra amount that we spend to do option D is definitely justified because it yields more benefits than the additional costs. All right. So on your way out, please remember to pick up your papers. There's 2 different homework assignments here that you can collect. And we'll meet back here in the computer lab again on Thursday. Just one moment.